Thank you very much. My name is Hannes, and I'm a front-end architect here at the Atlassian headquarters. It's my very first time here at SydJS, so thanks for having me. It's great to be here. Before I start my actual talk, I need to do a bit of a talk about my talk, go on a bit of a meta level. So this talk was originally delivered at the AWS summit here in Sydney a couple of months ago, and the audience there is very much focused on the services world, very backend heavy. So the talk today may be a bit more abstract and a bit more philosophical than what you usually get here at SydJS, but I think it could spark some interesting conversations. So I hope you get some value out of it. So enough with the meta. Let's get to the actual talk. So over the last 2 years, I've been very much focused on Jira, and my team and I have been busy with moving Jira from something like this to something like that. Oh, pretty. And that's a big UI UX update. But we also took the opportunity to move Jira to a modern stack. So there's a bit of logo porn behind me, but it really boils down to a React stack, right? React is the fabric that brings all the libraries together. And our new React-based code base is today well above 1 million lines of code, and it has a total of 400 contributors, roughly 200 contributors per month. So that's a significant piece of software, right? And that made me reflect a little bit on the history of software engineering, right? Where traditionally the world looked a lot like this, right? Where a lot of the heavy lifting, a lot of the architectural complexity, a lot of the system design was happening on the back end, and the front end was a relatively thin layer that was primarily concerned with making things look, pleasant. This is changing, right? Today we're seeing a lot of the complexity that was traditionally associated with the back end also on the front end. A lot of the matters of questions of scale, and of course the back end didn't get any easier, right? But keep in mind that we have spent 30, 40, maybe 50 years answering questions on how to build scalable systems on the back end, right? A lot of smart minds have been thinking about this, and I think it would be irresponsible for us if we would not think about which ideas and which smart concepts that established in the backend world we could move over to the front end, and how. It's absolutely critical for us to think about that. And this leads me to the topic of my talk today. I would like to discuss with you or share with you 5 lessons from system engineering on the backend, and classify them in terms of how we can transfer them over to the front end. The first category would be adopt. So that's something that it works on the back end, and we can just move it over to the front end. Problem solved. No action needed. Second category is the rethink category. So these are lessons that can generally be applied, but we may have to look at them a little bit differently. And the last category would be stop. So that's stuff that worked on the back end, but just doesn't work on the front end. Right? Can't do it. So that's the plan for today. Let me get straight into it. Lesson number 1, including a typo, I apologize for that, is decomposition. I think we, all been there, done that, dealing with some kind of a large monolithic legacy system and transforming that into a microservices architecture. Right? This is where providers like AWS or Azure really shine. And microservices are great, right? They have a lot of qualities that we really like. They are encapsulated, so they expose a clearly defined API. They have a clearly defined scope, so they deal with one concern and one concern only. And they are composable, right? You can compose them into something bigger. But these qualities, right, being encapsulated, having a scope, being composable, these are universal engineering qualities. They apply to almost any field of engineering. And we also really like them in the front end. Interestingly enough, there is a concept in the front end that implements a lot of these concepts pretty well, a lot of these qualities pretty well, and that's components. So let me take a step back and look at the Jira UI, right? If 2 Atlassian engineers talk to each other, they barely talk about the UI holistically as one big thing, right? They would much rather talk about the navigation component, which takes care of all things navigation and is owned by a dedicated navigation team. Or they would talk about the board component, which takes care of all kind of board concerns and is owned by a dedicated board team. Or they would talk about the issue component, which takes care of all things issue and is owned by a dedicated issue team. And this concept is recursive, right? Like you can break this further down into a header, into a sidebar, into a main content area. So what are components? Components to me are really, a component takes care of the visual representation and or the state management and or the data fetching of a particular concern of your UI, right? But most importantly, that logic is encapsulated and accessible through a clearly defined API. So I'm using the React lingo here, but it's really a concept that is independent of React. And this encapsulation is such a core concept, right? Imagine a Jira developer wanting to show an issue, which is a reasonably complex piece of code. Really, all they need to do is mount an issue component and pass in the issue key, and everything else is taken care of by the issue component. That's beautiful. Now, the concept of components is by no means new, right? You can actually trace that back to the mid-2000s, to Mood tools, and maybe even earlier than that. But I think React as a framework, I think was the first framework that truly nailed the syntax and made the concept truly accessible to everyone. So I think that was a big achievement. There's another quality of microservices that we really, really like, and that's independence. Right? Like I can write my microservice in Kotlin and deploy it to AWS, and you can write your microservice in Haskell and deploy it to Azure. That's all fine, that's all great, that works. And that's a good thing. Now, this concept of independence has sparked a very interesting debate in our community, right? And that's the debate around micro frontends. And so let's think about that a little bit more. Now that we have some kind of a model of components that have a clearly defined API, it's not unreasonable to push this a little bit further and say, well, look, can one component be implemented using React and another component be implemented using Ember and the third one be implemented using vanilla JavaScript? Well, that is a very interesting conversation, right? I'm very excited about that, and I think there's a lot of potential. But at the same time, we need to be mindful that there are fundamental differences between the backend and the front end. And I think the number one difference here is really this one, the browser, right? We need to keep in mind that the browser provides a shared runtime for our web application. The browser today does not have any concept of isolation of code within one window, right? If one component is slow, everything is slow. If one component blows up, everything blows up. The only thing that the browser has that is kind of the closest to true isolation are iframes, but that comes with big caveats and also has certain implications that I will talk about in a second. Because the other thing that we need to think about is, well, there is a human being in front of the browser, and that human being is the reason why we all have a job, right? It's a customer. And that human being expects a fast, consistent, delightful experience, right? And it is our responsibility as front-end engineers to provide that experience. And this is pretty hard. I think we can all agree on that, right? And it is just much, much harder if every part of your application is implemented in a completely different tech stack and run in a completely different way. Not impossible, just very, very hard. So when we discuss micro frontends here at Atlassian and in the Jira team, to us it's not kind of a black or white thing, right? Where something is a micro frontend or something is not a micro frontend. There are 100 shades of gray between that. And it's a spectrum. It's a spectrum of independence. How independent do you want your components to be from each other? And I think that's something where we all need to think really, really hard and come to form an opinion that applies to the problem that we have in front of us. So the first lesson, decomposition, I think absolutely something that we can learn from the backend and adopt. But we need to look at it a little bit differently, right? There are a couple of caveats that we need to take into account. The second lesson that I would like to share, again with a typo, is do not big bang, right? I think when we have a monolithic structure in front of us, we all would like to take a big hammer and smash it into 1,000 pieces. In reality, this doesn't work, right? The way that you do it in a traditional backend architecture is you kind of carve off bits and pieces from the edges until your monolith gets smaller and smaller and smaller and smaller and smaller, and ultimately disappears. In the front end, I think we follow a very similar. We do same but different, right? At Atlassian, we talk a lot about moving from an inside-out strategy to an outside-in strategy. So what does that mean? Well, if you modernize a legacy application, you kind of start with the legacy application, right? And it is a very natural thing to do to kind of replace, certain components by their modern counterparts. And these components, maybe a button here and maybe some panel here, there. These components can then kind of gradually grow and become bigger. And that's a pattern that is very well supported by React, and it makes a lot of sense. But at some point, what we saw is that we got to that point where these islands of modern code start bumping against each other. And it becomes kind of awkward, right? Like everything becomes a bit hard and a bit weird. And that's a really good indication that you want to actually move to what we call an outside-in model, where your application is fundamentally modern, like the routing would be owned by the modern stack, the page layout would be owned by the modern stack, and you may have islands of legacy code in your code base, but they would get smaller and smaller and smaller. Another way to look at that is kind of as a complexity curve, right? With an inside-out model, it's very easy to start, you just replace one component by a new one, but it kind of gets harder and harder and harder. Where with the outside-in model, you need to make a lot of very complex decisions early on, but then it would get simpler and simpler and simpler. So the challenge is really to find that sweet spot where you move from the one to the other. So don't big bang, again, something that we can absolutely learn from the past. Again, something that we need to apply a little bit differently. The third lesson that I would like to talk about is scaling vertically and horizontally. In the backend world, these are very established concepts where you scale vertically by getting a bigger machine, and you scale horizontally by just getting more and more machines. And typically you start somewhere in the bottom left corner with one small machine, and then you kind of work your way up to the top right corner. In the front end, this is fundamentally different. We need to keep in mind that your application is, by definition and always, executed in 1 million runtimes all over the world. That runtime is the browser, right? This is how the web works, which means that large parts of this chart are simply inaccessible to us, right? We radically scale. It's a radically horizontal scaling. In the vertical axis, that's really kind of the hardware of our customer. That's something we can't really control, right? Typically, the developer has the better hardware than the customer. So what that means is that we kind of need to optimize for some kind of reasonable lower end that we can expect, which really positions us at the bottom right corner. And this is what we have to deal with, right? So there's no call to action here. It's just something to be mindful. And I think this is really the gist of web performance engineering. At Atlassian, we also use the terminology of scaling horizontally and vertically in a slightly different context. We often talk about horizontal scaling when we talk about the number of routes in an application, the number of distinct experiences. And we talk about vertical scaling when we talk about the richness of these experiences, right? You can have a very simple experience or you can have a very complex experience. And as your application grows, you typically end up with a lot of very complex experiences. Interestingly, the horizontal axis, the number of routes, you can often solve quite elegantly on a platform level, right? You can build the infrastructure that takes care of routing, of code splitting, of async loading, and the everyday feature developer doesn't really have to bother themselves with it. That's much harder on the vertical axis, where you really rely on education and conventions. So again, scaling vertically and horizontally, the concepts absolutely make sense in the front-end world. Again, we need to apply a distinct angle to them. Being opinionated, that's an interesting one. Keep in mind, you can have the most awesome teams in the world. Your rocket scientists working in autonomous, self-contained teams, and that's great. But we always need to keep in mind that these teams all operate on a shared limited resource, and that's the browser. And in the history of mankind, there was really only one sustainable way to operate on a shared limited resource, and that's through rules and conventions. So at Atlassian, we made a relatively big effort to align on certain things. We started an initiative called Tangerine. That's actually the slide that I used back then to pitch it to the team. And the goal is to align on the patterns and practices and technologies that we want each and every team that contributes to Jira to follow. As you can imagine, that's a pretty hard thing to do, but we really managed to transform our front-end code base from a very mixed basket of fruits to something that looks a little bit more like that. Right? Like obviously, things, the one component is a bit smaller, the other component is a bit larger, the one component is a bit sweeter, the other one is a bit sour, but they should at least follow the basic conventions that you establish. We're quite proud of that, so we consider making this open source. Not there yet, but stay tuned. So being opinionated, I think everybody, we all are opinionated. I would argue that in the front-end world, you even want to be a bit more opinionated. Which brings me to my last lesson, automation. You can have the best conventions, the best rules in the world. They are completely useless if nobody follows them. And we are all humans, right? As much as we want to follow rules, as much as we want to follow conventions, we make mistakes. Things slip through. That's very natural. Robots don't make mistakes. So at Atlassian, we're kind of borderline obsessed with all kinds of static analysis and all kind of tooling, especially ESLint. And we actually have a huge number of custom ESLint rules that we wrote ourselves that implements the convention and rules we want to establish. I can really only recommend that to everyone to have a look into how to write your own ESLint rules. It is actually a pleasure. A lot of these rules are auto-fixable, so when you write code in the Jira code base, you can have a quite interesting experience, a bit of an unusual experience, because you press save and suddenly everything in front of you changes. So I just want to brag with one of my favorite rules, which is the import order rule. So if you look at that, there are a long list of imports, and there's pure chaos, right? There are some imports from some relative imports, some up the hierarchy, down the hierarchy, absolute imports, library imports, first-party library imports, third-party library imports. I hate it. If you develop on Jira, you just press save, and then you get this. Beautiful, look at that. It's all kind of grouped by by what kind of import it is, and there's some kind of semantic grouping. I love it. Fantastic. Just wanted to brag with that. And we also implemented a tool called Stricter, which is essentially like ESLint, but for your file system. So there's a couple of rules to that. Really good one is the circular dependency checker. So it tests for circular dependencies, but not only on file level, but on folder level. Very interesting. And don't attempt to read that. I just want to demonstrate how opinionated we are. So this is the so-called project structure rule that defines exactly which kind of folders and files you can have in your package. And it really means that all our packages and all our libraries look exactly the same, which is nice. This Stricter actually is open source. So if you're interested in trying it out and contributing, it's /Stricter. So automation, I think automation has a long history in computer science, and everybody's doing it to a certain degree. I would again argue that in the front end, you'd want to do it even more. Which brings me to my final summary here. We talked about 5 lessons, 5 dimensions: decomposition, don't big bang, scaling horizontally and vertically, being opinionated, and to automate everything. And you may have noticed that I was a little bit sneaky when introducing these 3 categories, because in reality they all fall into the same, which is to resync. And what I really want to say is all of the lessons that we learned in 30 or 40 years of system engineering on the backend can be applied to the front end in one way or the other, but we really need to think about them. We really need to understand what the implications are and make the necessary changes. Thank you very much. That's it for me.